Hello, everybody. Let's get started. So this session will be about how you get machine learning to production, and that's been my main goal for quite some time now. So I work as a lead architect within data and AI platforms. That's also the category that I'm an MVP in, so AI platform. I've been that now since this year, so it's my first year in the program. And the solution accelerator that I'll be talking about is called Enterprise Scale AI Factory. And it's really just a combination of AI-ready infrastructure with a lot of automation, and together with a lot of templates, both for data ops, MLOps, and Gen AI ops. But I'll try to focus more on the ML side, but I will mention some parts about the Gen AI part because it's quite similar actually how you do that. But just to get started, how many in the room here are actually working with machine learning? And are you data scientists? Yeah, good. But speaking of that, one thing I've actually seen and working with it for quite some time is that it's really hard to get things actually into the production. And mostly why that is because the role as a data scientist, I mean, it says it in the name, it's a scientific kind of role. So it's about like exploration and testing things out. It's not like you're not that used to usually to get things to production because that's not in the role, but you still have the obligation and people are expecting you to get your things into production either way. So this accelerator is just for that, to try to help out and accelerate actually getting it to production. That's the point of it. A little bit about me. In my spare time, I really love to dance. So I dance quite a lot and do a lot of outdoor activity. So I have dance practice like 3 times a week. It's ballroom dancing, salsa, bachata, and also Berg, the Swedish dance. I have a little bit over a decade in the tech industry with around 8 years focusing on cloud specifically. But my background is in operations. So I come from the other side around. So I started out hosting data centers and then went into cloud more as an operation kind of role. But I'm always trying to enable and help all the other roles. That's how I see the operation role really being and what the benefit of it is. I'm also part of the Microsoft Responsible AI Innovation Center in Sweden. So we do a lot of like hackathons and help companies out in that way to get responsible AI out, and do a lot of public speaking such as this and contribute to open source in different kinds of ways. As this solution accelerator, it is open source, Microsoft, MIT licensed. So it's not a owned property by anyone, it's just open source. And I'm one of the contributors to that. So we have different kinds of categories of AI, of course. What most people are talking about at the moment and what is really booming and hyping is generative AI, of course. So like the ChatGPT experience using large language models or small language models for that case as well. Just generating text, image, summarizing things, doing videos, stuff like that. But then you also have the discriminative AI, or also called classical AI. It's been a term that's being used more and more now, which is the machine learning, deep learning, doing predictions, visions, that sort of use cases. And I'll try to focus more about that. But the scope of the AI factory, to just set that context now first. I mean, you have a lot of like off-the-shelf products, such as like 365 Copilot and all the different like Copilots that exist in the Microsoft sphere. And then you also have GitHub Copilot to generate code as a developer. But when it comes to things, when you can't solve it with these off-the-shelf products, then you need to include custom generative AI. And that part is what we're including and trying to accelerate within the AI factory. So when the Copilot Studio and things doesn't do enough, then you need to build more things yourself. And then you can utilize the AI factory for that specifically. So we're utilizing the AI Studio, Azure OpenAI, and some other services built together in that sort of sense. And also we have the discriminative AI part as well. So some off-the-shelf product, for example, the cognitive services to handle vision, speech, language, those kinds of things. And also Azure Machine Learning for more custom machine learning projects that you need to run. So that is part of it. And we have a lot of Gen AI ops, data ops, and machine learning, MLOps as well in that. And we try to integrate this together. So that's just the context of what we're trying to use here. And you can use all of these services through the Azure AI Studio because all the AI services are available from there. So that is also part of this. Just some different AI types and some use cases that we run. I've been part of some of these, but not all of them, because I've also did projects with the AI factory out at different companies, but other companies are using it as well. But for example, the Epiroc case here is a project I was part of that we did like prediction of steel quality. More specifically, was on the steel hardening part of it. And in that case, we utilized the custom machine learning part here. So it was more MLOps, data ops that we utilized. And in another case with Sweco, it was utilized with the generative AI part. So more building custom generative AI was that case. I was not part of that, but they utilized this AI factory there as well. And there are some other references as well. If you want to look it up, you can see it on the public customer references on Microsoft's page there. But why are we at Society part of this? Well, we've been like a partner, so we're not. It's not that we have done this with Society. We are one of the AI factory ready partners. So we know how to utilize this and can go straight into actually doing the use cases in the solution accelerator. So there are some AI factory ready partners as well, and we're one of them. But we've been running this, as you can see here, since 2019 with SAS was one of the first companies that used it. So what is the AI factory then? Well, it's a combination of tools, processes, and people. So you have a lot of templates for the infrastructure as code side of this, and also templates for supporting the process of data ops, MLOps, and Gen AI ops. And also people, because I mean, there's a lot of need for different kinds of roles within this context and skilling to be able to utilize this accelerator. So that's a part as well. And all of this is what we're trying to accelerate with this factory. So there are actually 4 components and a lot of different assets part of this. So one of them is we have AI-ready landing zones. So it's in the cloud adoption framework landing zone way of thinking, which means that we can provision and deploy this both in a brownfield context and also in greenfield context as well. So you have like security from all of the well-architected framework and cloud adoption framework parts built on with a lot of automation to be able to do this. And the other part is we have data lake templates, which enables you to be able to do data mesh within the company as well. And we're utilizing the medallion concept of how we process data in between the different layers, or the bronze, silver, gold concept. When we can also utilize IoT part of this for the streaming data sets. And this is really a battle-tested lake design, because we've been running this since 2018-19, and it's been working really, really well for that. And then, of course, the data ops, MLOps, Gen AI ops, end-to-end templates. So it's more focusing on configuring, not building everything from scratch every time. So you just need to configure your parts for your specific project, what you want to do, instead of building it right away. So it's these 2 things together. So the AI-ready infrastructure together with these templates, that was the biggest part of this actual acceleration effect that you get. And I'll get more into that later on. But then you also have the scale and delivery part. So because everything is done by code and with templates, everything always looks the same. So if you go into a project, you know exactly how it is configured, where you should start and what you should do. You don't need to figure things out. So if you know this accelerator and this concept, you can go straight into actually doing the use cases instead. And from day one, you have the full security and able to go to production when you start it. So if we have more, we're getting more and more partners that are AI factory ready, so they can utilize this. And yeah, it's a lot of code behind this, of course. So it's 97 bicep templates, because we utilize bicep for the infrastructure deployment. We are doing Terraform at the moment as well, but it's bicep that we use so far. And 109 files of Python. So a lot of boilerplate coding, of course. So you don't need to do that yourself. And some other languages that's being utilized as well for different kinds of parts of it. But the infrastructure side, I mean, the pink box is what you get with the AI factory. But the other things outside of this is the cloud adoption framework, enterprise scale landing zones, what it's called. So it's how to utilize landing zones in Azure and how you do that. So we're mapping it completely into this kind of architecture. So you get a dev, stage, and production environment, and you can utilize, as you see here, some of them are machine learning projects, and some of them are generative AI projects. So you can do both of that in this infrastructure. So you get AI-ready infrastructure in an already existing architecture pattern. And because we're utilizing this pattern, of course, then you can do it both in a greenfield. So if you have nothing in Azure to start off, you need to set up, of course, your enterprise scale landing zones to start off. And that takes around like 4 to 16 hours because there's a lot of automation to be able to do that as well. A lot of configuration, of course, but as you see here, there's like ready to deploy templates for that. And then you set up the AI factory, which takes around 4 hours with configuration. And in a brownfield context, if you already have this other part, you can just go right into deploying the AI factory then instead. And you get all of the policies, configuration, and security from these the enterprise scale landing zone way of doing like infrastructure. So that's included into this as well. And it's been part of the cloud adoption framework since 2020. And some key points about this, I mean, it's about accelerating time to market. So actually getting things out to production as fast as possible. It's one of the goals, making it repeatable. So you can do it the same way all the time and repeat the projects. And yeah, about optimizing the team setup, having an operational strategy for it. A lot of reusable templates then, of course, is needed for that. And architectural patterns, different kinds of patterns. And this is part of it. And as you see here in the bottom, we have actually had this GitHub repo as an outside, not an Azure repo itself. It's been a Microsoft employee that's been hosting it for quite some time, but we're just right now we are transitioning it into an Azure repository instead. So it's going to be Microsoft hosted fully now. But still, it's MIT license, so everybody can go in and yeah, it's completely open sourced, all of it. There's nothing behind it at all. It's just all open source. And you get 2 packages of services, as I already mentioned. So you have the classical AI part, which lets you run machine learning, deep learning, prediction, vision cases, all of that. And we have that part of it since 2019. It's been unbreaking pipelines since 2019. And from this year, we included Gen AI projects as well, which makes you able to run like RAG use cases. You can do fine tuning or like agentic patterns as well is part of it. So you can do that. And that's since this year. So it's 2 different packages of services. And the 2 architectures look like this. So this is actually what you get into every project that you start running. So you have the option in the machine learning part of the CC to run it either on Databricks or in Azure Machine Learning, or you can combine it. I mean, you can use compute in Databricks, running it in Azure Machine Learning, and utilizing those services back and forward. And there are some optional services as well. For example, you can utilize the Microsoft OneLake as storage if you want to, and you can have Fabric as a presentation layer to get your reports up in Power BI, or you can just skip those parts. It's optional with like just feature toggling. Yeah, I want this or not. And the same goes for the generative AI part. You can the optional service there is to run it on Azure Container Apps or in Azure Kubernetes services, and actually running the agentic patterns. So you get like AutoGen and semantic kernel or things like that to make it possible to run more agentic patterns in that. And all of this is connected to personas. So that's more the person part of it. And as I said, I mean, you need different kinds of roles to be able to run this. So for some parts, as you see here, there's just one role doing it. And in some parts you collaborate together. But to connect that a little bit more in the actual process, when you do it, it looks a little bit more like this. So in some parts you have write, so you're actually writing or developing code and doing things in some parts of it. And in some parts you're just either fetching things from like an API or consuming things, but not writing, so more of a read mode. And in the production phase, as you see, it's only the actual pipelines, both in stage and production. It's only the pipelines or the build agents that actually are writing in there. There's never anybody else in any role, like an actual person going in and writing there. He's just consuming things from it. So you always just publish to dev, and all of the other things is just fully automated out there. So you don't need that much like actual coding or writing when you go to staging and production. And there's a lot more about this, so I'll just put up the link afterwards. We have a lot of documentation, so I'll get to that in the end here. But how do you run an actual project if you go into the machine learning part? Well, first off, you have your ingestion. I mean, you need to get your data somehow into the project that you're going to utilize. We have two different patterns for that. It's both batching, and for the batching part, we're utilizing Azure Data Factory. We have templates for that. You can, of course, change that with like Databricks and things like that, but the templates that we have is for Data Factory. Most likely, we will do it into more of a Fabric sort of sense as well, but that's what exists at the moment. And other than that, you have your more real-time streaming part for the ingestion. So, for example, things coming from IoT or things like that. So if you want to do streaming for your scoring or actually mapping into your data lake. But after that, where you store it, we have our data lake pattern. And there's two parts to that. You have both your master part of the data lake, and that part is 100% generic. It's not connected specifically to machine learning. Which is, you can also have you can utilize the Delta Lake format in this part. It doesn't need to be anything else, so you can do other kinds of patterns as well. And then you have your project. And in the project layer, it is Parquet specifically. And in here, it is structured in a specific sense, so it can be utilized for all the projects. And I'll also get a little bit more into that later on, when we go into an actual project, how it looks when you run it. But after that, you have your prep and training. So you're prepping your data, doing your feature engineering, to actually have it ready to use for your model, splitting it up into training and testing data sets. And when you run that, you of course want to deploy it. And for that, we're utilizing Azure Kubernetes services, so Kubernetes clusters. But in some cases, when you deploy it for online scoring, you'll see that, okay, this actually performed worse than before. So might have data drift or something like that. Then you need to trigger a retraining for it. And not only that, if you get data drift, you can actually trigger the ingestion part for that as well. So you need to have new data, of course, in that sense. And then you go back, retrain it, figure it out, and you deploy a new model. So you have your new model out to the clusters. And another pattern that we have, because the data lake has the master layer, which is generic, you can also utilize that directly into Fabric for more like analytical purposes. So if you have like advanced analytic cases that don't need machine learning, then you can utilize this lake for that, straight into Fabric and presenting it in Power BI. Yeah, so how do you set it up then, and how do you actually create more projects and do these kinds of things and onboard new teams and people to this? Well, to start off, the deployment of the actual factory, it comes in two parts. We have a common layer, which is sort of the glue in between all projects. You have your data lake, your networking, all the shared resources, so to say, which are being deployed in three environments. So you have your dev stage and production environment. And then you have your projects. And the default IP plan that we have makes it able to run everywhere from 1 to 250 projects. But I mean, it's just the IP plan that is the limit. If you bump that up, I mean, there is no limit on how many projects you can run in this, really. So yeah. And when you deploy that, you first off, of course, deploy the common part, and then you go out with all your projects afterwards. So each environment gets its own landing zone, so an own subscription that you have, which has its own data lake, security isolation, and its own network. And the only way the network can talk to other things is horizontally, so you can talk in between from dev to test to production, because of course you want to compare the models in between these parts. But it's the only way how it actually is allowed to communicate. And when it's up and running and you want a new product, this is an example that you can do. I mean, some companies decide to connect it into their ITSM system, and so have it as you can order it from a ticket. Then you just need to write in some parameters, what kind of model, what kind of project type it is, if it's a machine learning or if it's a generative AI case, and then just click it out. You can start the automation, wait 30 minutes, and you have your project. You have your infrastructure up and running. So yeah. That's really, it goes quite fast, and then you have your new project and your next up to how many you need. But these projects, it's not, it can be one to many models. So it doesn't need to be one model per project. It's more of a team collaboration. So you have your team space where you work. So you can utilize that for more models and more use cases, I would say. And a little bit deeper, if you go into the MLOps and GenAI ops, so there is like a maturity stage level on this. And what I found is quite funny. Usually the last part is not part of these maturity stages. So usually you just have the inner loop. And when you go from one level to the next, the only thing that you're doing is you're just automating more and more things all the time. But the last part here, the outer loop, is usually not included at all. But we have that in this accelerator. And that means more you have the dev, test, production environments that you can go over, and you compare and have a feedback loop over this all the time. And also the enterprise security and all of that part. But that's usually not part of it, but we have that as well here. So yeah, how it looks a little bit when you actually work then. First off, as a developer, if you check something in, you usually do it just locally or you do it in a dev environment. And when you do it in the dev environment, you have your inner loop. That's the next part of automation. So you add on so you can retrain, fine-tune it, do things like that. You calculate your test scoring, seeing how it actually behaves, and compare it and bump the model to the next version if it performs better. And then you, of course, want to automate away so it's little like people interaction at all. So you have your Azure DevOps or GitHub is what we're using for the automation parts to actually deploy and do the projects. But next off, is the outer loop as well. So when you've done it and you see it actually performs better in your dev environment, then you want to do a comparison and register it to the next part, so in your staging environment. So you want to deploy it and smoke test it there first. So you bump the model in stage. And when you tested it out, seeing that it performs even better, of course, then you want to deploy it to production. Then you do that and bump the model there. Then you've gone all the way through. So that's the process, how it looks when you actually run a project. So it is the AI-ready infrastructure. You have your dev, stage, production environment together with the templates for running machine learning and GenAI ops. So MLOps and GenAI ops. That together makes it so you have the environment, the infrastructure, and you have the templating and things to make it possible to go and move in between dev, stage, and production as well. And that's the process and the AI infrastructure together, the benefit of it. And a little bit more, if we go deeper into the actual MLOps part, we can see exactly how the pipelines themselves look when you do this. So first off, you have your data ops, your ingestion part, and in here you have you're moving the data first off from the master folder into your project. So you can have, for example, a daily scoring if you have that as a set timer, as a variable for your project. You want to score it every day. So you take one part and push it to the training pipeline, which will retrain and train the model. And if it actually performs better, it will be that model, of course, that goes into the inference part that can be utilized and being used. And you, at the same time, push the same data set into the actual inference. So you can score based on that new data that comes in. And you put your prediction back into the data lake as well. But I mentioned that I wanted to go a little bit more into the actual data lake design and why that is important. So how you set your variables for your project when you get started. And we have these settings, that is the data part of it. So you specify what your model number is, what it is. And what you see here, the folder name is the actual folder name, of course, in the data lake. And because it is structured in the same way, the data lake design every time, this is pretty much the only thing you need to do. So when you add in the data there, if you're just pointing in and saying, I have this folder, this is my model, and these data sets, then you actually, if you have one data set, that will be part of the pipelining. So when you run the actual pipelines, it will include that. But in other cases, if you have, for example, 4 data sets, then that will be part of the pipelines as well, being built automatically into it and utilized. So this is a way of not getting a data swamp. Because you have this structure and you're doing it this way, nobody needs to ever know exactly how the structure looks. It's only the data team that needs to know that. Not anybody working in this actual project. You only need to reference your actual data set folder names. That's it. So it makes it a lot easier to stay away from the swamp. Shrek. But when you start and run a new product, this is one of the pipelines that we have. I'll just show this demo example. But if you start off here in the side here, whoop. Yep, yeah, exactly. You said it's your fault. So there, I think it's back. Oh. Good. No. There we go. Now in the side here, when we start off this pipeline, you see we have no folder called pipelines. And when we run it, the first part where it does, it's just putting up your pipelines like placeholder folder to get this running. And the next part, what you do is you're auto-generating like a snapshot folder. And this will fill this new map. And it will include everything that is going to be part of the pipeline. So for example, if you want to go in here now, when you've done this, you can just change the code. I mean, if you want to change, for example, your splitting logic, if you want to break it up so you have more data into the training data set, or change what models it's actually going to run over, the AutoML part, which it's going to use, or how the feature engineering is, you can just go in and change all of these files. So it is specific steps for all the steps, and this is what will actually build the pipelines in its turn. So when you've gone from this and you go over and actually build the training pipeline, it will utilize these files. So it's just a lot of boilerplating that it builds for you. You go in, fix your own logic, run this to actually build the training pipeline, and then you execute it. And as you see, it's not that much lines of code. So if you have a starting off project that you just want to try and run over a lot of different models and see how it actually performs, it's quite easy and fast to get it up and running. There's not that much things you need to configure to start off. And then, of course, when you execute it, it will trigger it and run it as a remote pipeline in Azure Machine Learning. So in this case, we had 2 data sets. So it will do all of the going from in to silver, actually doing the feature engineering. When that feature engineering is done, it will take those 2 data sets, merge it together as a gold data set instead. And the part after that is to of course, split it and register it. So it will split it into a training and a test data set. Kick off, start the actual training. So run the training, and when the training is done, it will go and actually calculate the scoring based on the test data set that you split it up to. So it will build this full pipeline for you. And it's only these lines of code that I show you to get started. So you just need to configure all of these projects and then run these few lines of code to actually get it up. And after this, of course, you need to do into production mode, but this is the first step to get it up and running, just as an example. And when that is done, of course, what you're usually doing after that is going in and actually checking the metrics. Okay, how did it actually perform? Where am I on the predictability scale? I mean, is it performing well or not? So you get a lot of different kinds of metrics. And you can also go in and check, for example, the feature importance. So if you see, for example, that one kind of data set made a lot more sense, why it's predicting the way it does, you can see it here. So if it's something that is completely irrelevant, in some cases you might just want to remove that data set completely, or that feature completely, because it's not affecting the model itself. So you can go in and check all of that. And last off, as I said, there is a lot of documentation. So we have just some quick starts how you get it up and running in the GitHub repo. There is one part for the actual governance related, so how you actually set up the full factory. And then the other part is about like how the actual projects themselves work. So all of the MLOps, GenAIOps, that is fully explained in this documentation as well. And it will, as I said, soon be moved over, so it will be an Azure repo, but you can go in and check it out now if you want to as well. It's called Enterprise Scale AI Factory, if you look for that. Yeah, and I think that is pretty much it for me. So you can start off if you have any questions about things. Yeah. Mm. Okay, yeah. I mean, that is the full step as you saw with the into silver part. The basic of this example, it's extremely simple. It's just removing like dashes or things like that, like small things about it. But as it is just in separate files for it, you can go in and modify that completely how you want to do it yourself. It's just an example. It's just giving you like you can do this, this, and this, and just giving some example of that part. But it's fully customizable. So if you want to go in and change something completely, you can do that, of course. If you want to remove a column or do whatever, that's just fully up to you. It's just giving you some boilerplating for that. Yep. Mm-hmm. Parquet. Just for these examples that I showed you, that is tabular. But we have examples that we're utilizing that, like I started off with the off-the-shelf services. We're using cognitive services. We have some acceleration for that as well. I just didn't show that example. Yeah, and I mean all of it. If you want to change something in it, it's just you can change it. It's just for these specific accelerated parts for machine learning cases that is tabular. And then it's really hard set like folder structures, and it needs to be Parquet because that's what we're using for that. But for the other parts, if it is, for example, vision or something, it is more general, and you can utilize the master structure of the data lake as well, and just add those kinds of data sets in there because there it can be like PNGs or whatever as well, and utilize that for the vision projects. Hmm? And no, I mean all of the splitting is done when you merged it to the goal data set, and then you do the splitting. So all the feature engineering is done before that. Yeah. Yeah. Good. Yeah. Any more questions? If not, then thank you for listening.